Welcome back again. So let us have the time simulation for this logic circuit. So our logic circuit was like this. So input was A, B and C. Output was X and Y. The name of this was G1, this one was G2 and this is G3. Here is a wire connection. Now, we will write the truth table for this corresponding to the time. Okay. Like for time 0, what happened? Or for time 0, time 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, like this. Now, what was our input? A, B and C. What was our output? Our output was XY, but we have some internal connections like E. So I would like to mention E here, then X and Y. Okay, suppose our input was 0, 0, 0 and on 20 nanosecond, A was changed into 1, but B and C was remained same. I am giving just a dot so that I don't make the mistake. On 30 nanosecond, let us consider that the input was same. But on 40 nanosecond, let us consider B also become 1 and C become 0. Let us consider that on 50 nanosecond, all of the input become 1. Now we will see, so it will be continued until the end. So we will make another subsection so that I don't make the mistake. Okay. So what would be the output? According to our program, the triggering time for G1 was 30. The triggering time for G3 was 20. Let me check it again. Yes. And for NOT gate, it was 10 nanosecond. So, when E is calculating for A and B, so I will get output on this gate, for this gate, after how many nanosecond? 30 nanosecond. So for 0, 0, we will get the output for 0, 0, we will get the output 0 after 30 nanosecond. So we got 0, 0 on 0 nanosecond, we will get the output on 30 nanosecond. That means on this level, we will get the 0. Okay. And how about the other one? We don't know. Okay, because we don't know what was the value before 0 second. So we can say don't care or we don't know. The same thing happened for these two. 0, 0, but 0, 0 was the input on 10 nanosecond. So you will get the output on 40 nanosecond. So for 0, 0, it should be 0. In the same way, if we consider this part, so for 1, 0, we will get again 0 since this is AND gate, but on 50 nanosecond. Again, we will get 0 on 60 nanosecond, but for these on 40 nanosecond, we got both A and B 1. So the output will become, we will got 1 on which time? 40 plus 30, that means 70 nanosecond. So on 70 nanosecond, our output will become 1. Okay, and it will be continued for all the inputs. So we can just continue 1, 1, 1, then 1, 1, 1. Actually, we will get, even for this one, we will get 2 more or 3 more ones. That is the concept. Okay. Now, let us consider, first we will get the value of y. We will consider x later. So, just let me change it. First y, then x. So, we will get the output y after how many nanoseconds? Just 10. So, on 0, it was 0 time, it was 0. So, we will get the output not get as 1 after how many nanoseconds? 10 nanoseconds. So, we will get 1 on 10 nanosecond, 1 on 20, 1 on 30, 1 on 40, 1 on 50, and after that 0, 0, 0, 0, 0, 0, 0, 0. Clear? Now, so in that case 0 to 10 nanosecond, we don't know the output, we don't know the value. Okay. Now, let us consider x. X is the output of E and Y. So, we will consider E and Y. Since, and the triggering time is 20. On 0's time, it was don't know. So, we will get the output as don't know after how many nanosecond? 20 nanosecond. So, on 20 nanosecond, we will get the output as don't know. And the previous two, of course, it should be don't know and don't know. Okay. Now, for this, since it's OR gate, it will become 1 if any one of the input become 1. So, we can see here, this input is don't know and 1. So, since this is OR gate, for OR gate, if any input is 1, then the output will become 1. So, we will get this output, but we will get it on 30. Since we get the input on 10 nanosecond, we will get corresponding output on 30 nanosecond 1. Okay. In the same way, we will get on 14 nanosecond 1. We will get 1. We will get 1. We will get 1. We will get 0. We will get 1. Then all are the same. 1, 1, 1, 1, and will be continued till we have the input. So, this is the way how we can get the timetable. Once again, for this input, our initial input was 0, 0, 0 for all A, B and C, but the input A changed on 20 nanosecond and input B was toggled on 40 nanosecond and input C was toggled in 50 nanosecond. So, for this input, we will get this type of output. So, if I tell you to draw the corresponding time diagram, you will just simply, you can just simply draw here, like if I say this is timing T, if I say this is, I used, I think 100 should be enough. So this is 50. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Let's consider 100. 100, okay? 10, 20, 30, 40, 50, 60, 70, 80, 90, 100 and go on. So, for y, if we draw the time diagram for y was don't know until 10 nanosecond. So, until 10 nanosecond, y was don't know. Okay? And until 60 nanosecond, that means it got 1 on 10 nanosecond, and it is continued until 59 nanosecond. That means on 60 it will become 0. Okay, it will become 0, and this 0 will be continued until the end. That is for y. For x, we found until 30 nanosecond. Okay, so until 30 nanosecond, until here, we found the output as don't know. Then we got 1 until 79 nanosecond. So until here we got 1. Then just for 10 nanosecond it becomes 0 and again become 1. So my drawing was very bad since it was a lower part of this board. So this is the corresponding time diagram. So in exam I will give you a logic circuit, then I will give the input timing, like on what time A or B or C will be changed, and then I will ask you to write the corresponding timetable, and I will ask you to draw the time diagram.